All right, hello. Here's your Unit 2 review for your semester exam. I've already completed the whole thing, so you have access to this completed version, but I'll explain problems as we go through. So for number 1, and this is really 1 through 4, they're all the same kind of question, end behavior statements. So remember what end behavior statements look like. But I've summarized how you can determine it over here. If you have an odd degree, that means your end behaviors are opposite. So one side goes up, one side goes down, but it could be the other way around. It could be up on this side, down on this side. Even degree, they have the same end behaviors. So both sides go up or both sides go down. And then to determine which side goes up or which side goes down, if your leading coefficient is positive, then it always goes up to the right, no matter what your degree is. And if your leading coefficient is negative, then it's going to go down to the right. So for this one, since we have a leading coefficient that's positive with an odd degree, positive leading coefficient means it goes up to the right. But since it's an odd degree, it's going to have opposite end behavior to the left, so it goes down to the left. And so that's what this means. As you look to the right, graph goes up. As you look to the left, graph goes down. You will have Desmos on the exam, though, so you could just look at the graphs of these to be able to answer these questions as well. But it's probably a little faster not to have to graph them, but you should have time to graph them, I think. So that's all of these, so you can kind of look at those. So to evaluate polynomials, you can either do direct substitution or synthetic substitution. Direct just means plug it in, so it's what you've always done. Just take 4, plug it in, plug it in. I've shown that work here. For synthetic, now we talked about synthetic division a long time ago, but it's the same process, and your remainder is the value you get if you plug -1 into this. So if the polynomial is rather large or uses large numbers, this process is actually faster, but sometimes this process might be faster. So it's really up to you which one you want to do. Or again, you can just use Desmos and you can type this function and then let x equal 4 from like a data table, type this function, let x equal -1, or you can type -1 into this and just type it straight into Desmos also. But on a multiple choice test, it's possible that some of the problems are the setup for synthetic, and so knowing how to do it will still be useful because the questions on a multiple choice test aren't always just asking you to get to the final answer. But in any case, you use the coefficients, so -1, 5. Now, normally there would be an x term here, but there isn't one, so you put a 0 in its place, and then the number at the end, 11. So you got to count down by exponents, 3, 2, x would have an exponent of 1, and then this has an exponent of 0. So anytime you count down and something's missing, you got to put a 0 in its place. And so those are these numbers, the coefficients. Bring the first one just straight down and then multiply these two together. After you multiply, write it here. Then you add these and then repeat. So you're going to multiply, add, and then multiply to get here and then add. And so 17 is what you get when you plug in -1. 17 is also the remainder if we divided this polynomial by x plus 1. Remember, for polynomial synthetic division, you divide by the 0 that comes from a bubble or a factor. So the factor would be x plus 1, giving us a 0 of x equals -1. Although in this case, it's not actually a 0, but it's still a number that you would use. Okay, on 7, the parentheses here are pointless. We're just adding, so combine like terms. You can see the highlighted colors match up and combine like terms. 8 is subtraction. So you have to distribute the negative sign. So the first step I did down here is switch everything. This became negative, this one became positive, this became negative, and this became negative, and then combine like terms. On 9, to cube something, it means multiply by itself 3 times. So first I squared it and got this, because you have to FOIL, so you got to do all that. And then I took that answer, put it over here, and then multiplied it by another x plus 2, because this is just x plus 2 squared, so we need another x plus 2 to get it cubed. And then, so I did red times both of these, which are what these are, purple times both of these, which are what these are, and green times both of these, which are what these are, and then combine like terms. You could also graph this on Desmos and graph your answer on Desmos, and if the graphs are the same, then you know your answer is right. And you can do that for a lot of problems. On 10, similar thing. I multiplied these two together first to get that, and then I multiplied that result by x minus 3. And again, I color-coded everything as I distributed, so you can see, and then combine like terms. All right, so using synthetic division, divide these. So this is what we talked about on the first page a little bit. This is a coefficient of 1, 9, 0x that we don't see. So that's that, and then minus 8. And I'll let you look at that. But again, you bring this first number down, multiply these two together, write your result here, and then add. And that's where you got that. And then multiply it and write your result here, and then add. So our remainder on this one happens to be 0, which means we divided by a factor. But remember, the actual answer, we're trying to divide this by this. These are the coefficients of the answer. So since we started the cubic and divided by something to the first power, you're going to end up with something to the second power. So it's 1x squared, 8x minus 8, which is that. Okay, same thing over here. I'm not going to go through the process again on the video, but it's the same thing. And here our remainder is 1, which means we did not divide by a factor here. But this result actually still is x squared minus 5x minus 5 plus 1 over what you divided by, which is x minus 5. So writing this is the same as writing like 3.5 when you do 7 divided by 2. It's, you have 3 with a remainder of 1 and you write it over your divisor. So that's what that is. All right, the zeros from the graph, just where it crosses the x-axis. Sketching graphs, so anything graphical on your exam, you can use Desmos, of course. You can use Desmos on the whole thing. So some of what you should be practicing as you're going through these problems is just how to use Desmos to answer the questions. Like, what is the question asking? What are you looking for? But in general, this is a shift to the right of the parent function. Remember, the parent function looks like this. So this shifts it right 3, which is why I have a vertical asymptote of 3 right there. The 4, the plus 4, shifts it up 4. I didn't label my asymptote, so there we go. And that's what this does. This, since it's negative, will flip it upside down. And then it's a stretch of 2, but the stretch is kind of hard to tell, really, because it doesn't stretch it a whole lot. It doesn't really change the shape a whole lot, but it does stretch it. But really, you just need to know the location of these two pieces. On this one, domain up here. Domain is always for these. Remember, it's negative infinity to a vertical asymptote to infinity. Or if you had a second vertical asymptote, you would go negative infinity to vertical asymptote to vertical asymptote to infinity. A lot of times we don't ask range about these problems because the range can get weird on when you have 3 pieces to the graph. So for 15, the domain, the only thing, remember, domain's coming from the bottom because you're not allowed to divide by 0. So that's negative 5, which is why I have a vertical asymptote at x equals negative 5 over here, which again, I didn't label. I'll label that. So this is x equals negative 5. This is y equals 2, and I'll show you where that comes from. So, but in any case, since x is not allowed to equal negative 5, here's our interval notation for that. Our horizontal asymptote is y equals 2 because, remember, Bill Gates, these are so small in comparison to other things, we don't care about those. So it's really just 2x over x, and 2x over x, you can cross out the x's and get 2. So y equals 2 is our horizontal asymptote, which we have right there. And then, to know if the pieces go up here and down here, you can find either x-intercepts or y-intercepts. Y-intercept is just when x is 0. So if you plug in 0 for x, these are gone, and you just get 2/5, which is the point I've indicated right here. So now you know you have to have a piece of the graph down here to pass through its y-intercept. And the other piece will be up here. You can also find x-intercepts, which is when the top is 0. And our x-intercept would be at negative 1. I didn't draw it entirely accurately because I based it off of this point only. But the top equals 0 when x is negative 1. And so our only x-intercept is over here. So this piece has to go up here because if it was down here, it would cross the x-axis somewhere around right there. And that can't happen because we already found the only x-intercept. Okay, horizontal asymptote for this one. Again, so you Bill Gates it. So as x gets really, really big, the bottom gets really big. And remember, small over big is really small. So it's going to trend towards 0. Same thing happens on this one. This part will trend towards 0, but then you add 7. So this graph is just this graph shifted up 7. So if this has a horizontal asymptote of y equals 0, this one's going to have one at 7. All right, and then we're simplifying things. So double bubble everything. The blue is this one, the orange is this one. And when you have bubbles on top and bottom that are the same, they cancel out. So this canceled with that. These two canceled, and those two canceled, leaving us with just that. Remember, if everything cancels on top, that leaves a 1 on top, not nothing. Same thing here, except this is division, so you have to flip these. because you multiply by the reciprocal. So I've already flipped them down here, and then I factored. So this is actually the bottom factored. This is the top factored, and cancel common factors again. Since we have the same factor twice on top, you can write it as x plus 4 squared, or write it as x plus 4 times x plus 4 is also okay. Simplify this one, so you got to get a common denominator. So this had x plus 5, and so did this, but this has x plus 3 and this doesn't. So multiply top and bottom by x plus 3. And so once you have a common denominator, you can make it a single fraction. So it's x minus 2 right here, plus 4 times x plus 3 right there. I just wrote it as a single fraction since I have a common denominator. I distributed, combined like terms. Okay, similar thing down here when you're solving for x. There's another way to do this one, but I did this one the way I figured you guys would probably do it. This has an x, this has a 3, this has a 3x. So this needs a 3 and this needs an x. So I multiply top and bottom by x, top and bottom by 3. Everything now is the same denominator, which means we can just set the numerators equal to each other. So 2x plus 12 equals 9, solve from there. And same thing down here. These both have x minus 3. This one doesn't. So I multiplied top and bottom by x minus 3. Distributed right here. And now I'm setting the numerators equal to each other. So 4 times this is 4x minus 12 plus 2 equals 5. And then you just solve that from there. And that's it. Good luck.